Hello everyone, welcome to Practically. We bring learning alive. So today we are having one shot on class 9 physics, that is gravitation chapter. Already maths and maths, chemistry, biology one shots are going on, and few topics already have completed. And today's session is on gravitation. Fine. Hope I am audible to you, whoever are watching. Am I audible? Just a respond. Am I audible? Am I audible? Whoever are watching. Just a minute. Am I audible? Okay, fine then. We'll enter into the session. Hope you all are doing good. Yeah, psychological fact. Hi. Okay, fine. So see here, it's one of the very interesting chapter. Gravitation is one of the interesting chapter. In class 9, according to the Term-2 NCERT, the chapter actually consists of gravitation part as well as fluid statics part also. But in Term-2, fluid statics part is not there. So only the gravitation topic is there for your Term-2 examination. Okay, fine. Hope I am audible and clear to each and everyone. You just respond. If I am audible, just say respond it as yes in the comments. I can see here. Anyone can respond? That's so crafty. Yeah, good evening. Yeah, fine. Thank you. Fine then. So okay, without delaying, I'm going to enter into the topic. And before that, already as I said in the beginning, one shot on class 9 are going on, and these are the sessions. And yeah, today is gravitation, 17th Feb, and then followed by you are having 18th, 21, 22nd, 23rd, 24th. 24th will be the last session, and that will be your mathematics. Okay, so every day we'll be having class from 6 to 8 p.m. Just like how we are having that today's session. Okay, fine then. Okay, fine. These are the one shots on class 9 NCERT, and this is for coding and one shots. And next session will be having on 19th Feb, and that will be the last session. Okay, and that timings are 8 to 9:30 p.m. Okay, fine. Gravitation. So gravity or gravitation, what is meant by gravity or gravitation? It's the property of attraction between the two objects. Any objects you may take. Property of attraction between any two objects you may consider. Okay, actually we know how the importance the property of gravitation is. You may take the rotation of the earth around the sun in the solar system. You may take any planet, or you may take a rotation of the moon, revolving, how moon is revolving around the earth in one particular orbit. So whatever, and even how we are bounded to the surface of the earth here. So when it comes to this topic, especially the gravitation, it's lively connected to the existence of the life. Okay, I can say it's one of the very important topic, rather than saying that it as it has come in the subject. Even if you see regular life, okay, practically when it comes to reality, it's playing a very important role. So we are going to discuss about the same thing, the property of attraction between any two objects. You may take any two objects that are consisting of certain mass, and mass is different here, weight is different, and even that classification also we are having, that also I will define you. Fine. Property of attraction I am saying. Why it will be an attractive force? Why can't it repels the object? Here that will be the basic nature of the property of gravitation. But when it comes to this force of attraction or force of repulsion, this gravitational force is a long range attractive force. It never ever repel the objects. It never ever repel the objects. It will be always attractive only. It won't repel the bodies. And it's a long range force. That means from the shorter distance, you may take the objects from here to here. Okay, let the distance is x meter to very long distances. You may take the distance between the sun and earth, or distance between the earth and moon. There is a force of attraction between those two bodies. And even you can take these two objects which are there in my hand. Between these two bodies also gravitational force of attraction is there. So from this small distance to such a very large distance, the force of attraction is there. That's why we are calling this gravitational force as long range force, and it's one of the fundamental force. Yeah, gaming fire army. Yeah, hi. So this gravitational force is one of the fundamental force. It's a long range force and it's an attractive force. We are going to talk about the attracting force that's existed here. Okay. Universal law of gravitation. We all know that Newton's observation, when he was sitting under the tree, the falling of the apple is just because of what? That's the force, or it's the pull that's exerted on the apple because of the earth. That's what we are calling it as gravity of earth, or earth's gravitational force. So here, that force, how was defined by the Newton, we are going to see. That's what we are calling it as universal law of gravitation. So what is the statement of universal law of gravitation? Fundamental statement, very important. The Newton's law of gravitation or universal law of gravitation states that force of attraction between any two objects in the universe is directly proportional to product of their masses. Okay, so it depends on the mass of the objects. How it is related? It's directly proportional to product of their masses and inversely proportional to square of the distance between them. Okay, so see here, suppose if I say if I consider any two objects which are having masses as m1 and m2, if they are separated by a distance or like this, then according to Newton's law of gravitation, that means according to the property of gravitation, between these two bodies the force of attraction is there. That force of attraction, say that is F. So that F is directly proportional to product of the mass of these two bodies and inversely proportional to square of the distance between them. Here let R is the distance between the two objects, then here it will become F inversely proportional to R square. So from these two we can write F proportional to m1 m2 by R square, And according to these rules, here if I remove the proportionality, we can place any constant. The constant here I am taking it as G, capital G, and then the final expression will become F is equals to G m1 m2 by r square. Alright, here G is a proportionality constant. What is that constant? Universal gravitational constant. It's universal gravitational constant. Okay, and the value of G here it is same throughout the universe. Between the any bodies you may take, not only on the surface of the earth, you may take any other planet or whatever the solar system in the universe, the value of G remains same. That's what we are calling it as universal gravitational constant, and it will be applicable to the any objects that's existed in the universe. So then value of G can be written as here 6.67 multiplied by 10 power minus 11 Newton meter square kg per minus 2. This is the unit of universal gravitational constant. So universal law of gravitation states that the force of attraction between any two objects in the universe is directly proportional to product of their masses and inversely proportional to square of the distance between them. If I say m1 and m2 are the two objects which are having the masses, if I say the two objects over here having masses m1 and m2, if they are separated by a distance r, then the force of attraction between those two objects can be written as F proportional to m1 m2 and F inversely proportional to r square. By combining these two, we can say F proportional to m1 m2 by r square. And here if you apply this gravitational constant, that means proportionality constant, F is equals to G m1 m2 by r square, whereas G is universal gravitational constant and the value of G is 6.67 into 10 power minus 11 Newton meter square kg power minus 2. This is capital G, which we are calling it as universal gravitational constant. Alright, the next one then, importance of the universal law of gravitation. See here, when it comes to importance, you may say that objects, how we are bounding to the surface of the earth. If there is no force of attraction here, then we can't stay at one particular place here. Our weight, that means the force exerted by our body, nothing but the weight is being pulled towards the center of the earth. So we are bounded to the surface of the earth, that means objects are bounded to the surface of the earth with the help of this gravitational force only. And next, the occurrence of the tides is because of gravitational force. Next, you may take the rotation of the planets around the sun, or the revolving the planets in their orbits around the sun is because of gravitational force only. So not only this, there are so many advantages. So in various ways this gravitational force will help to the existence of the lives. Okay, so you can say, you can list out all these points whatever I said. That's what the importance of the law of gravity, universal gravitation. Yeah, Aslam, hi. How are you, Aslam? Fine then. Yeah, there is a question here. The question is based on the universal law of gravitation. Let us see. The mass of the earth is 6 into 10 power 24 kg and that of the moon is 7.4 into 10 power 22 kg. If the distance between the earth and the moon is 3.84 into 10 power 5 kilometer, calculate the force exerted by the earth on the moon. Okay, take G value 6.7 into 10 power minus 11 Newton meter square kg power minus 2. Okay, so here earth and moon, two objects, these two are. Say you are given this is mass of the earth and this is mass of the moon. There is a force of attraction between them. How much it is? See here then, I am writing the given data. See in the examination, while solving the numericals especially, even in many classes I said, now also again I am saying for class 9, this is a very important stage for you. Next year almost your 9th standard completed and most of the children have written their examinations also in your schools. So next you will be in a class 10 where you have to give your board examination, right? So see, while solving the numericals especially, you have to read the question first, understand the given data, what is given and what is needed to be found. That things you have to understand and then you enter into the solving it. And while solving also there is certain procedure. Write the given data first. And if it is formula based numerical, just recall the suitable formula, substitute the data in the formula and then simplify it, get the answer. Even while writing the answer also you have to cross check. If the physical quantities, whatever that you are going to obtain, suppose if the answer is involved or associated with some physical quantities, if it is having units, don't forget to place the unit. If it is not having, then leave it like that. So be careful while solving the numericals. Alright, here given data, mass of the earth is given. Mass of earth, say ME, is what? 6 multiplied by 10 power 24 kg. And mass of moon is given. Mass of moon, say it is 7.4 into 10 power 22 kg. Distance between the earth and moon is given. That's a distance of separation. Okay. Distance between the earth and moon, say it as r, which is equals to 3.84 into 10 power 5 kilometer is given. I am converting it into meters. 3.84 into 10 power 8 meters, since 1 kilometer is equals to 1000 meter. Then here we know that from the Newton's law of gravitation, F is equals to g m1 m2 by r square. As here I am taking mass of the earth as well as mass of the moon, so me into m by r square. If you substitute all these values here, that will be like this. Then multiplied by 7.4 into 10 power 22, and distance is 3.84 into 10 power 8 whole square. Now you have to simplify it, and if you simplify you will get averagely almost 2.01 into 10 power 20 Newton. Yes, as we are calculating the force here, as unit of force is Newton, and don't think that I have simplified in my mind. This is a textbook based example. So I am writing the what is that answer here directly. Okay, if you simplify also you'll get the same. You can cross check. Yeah, Aslam, fine. I am fine, Aslam. Okay, so this is the way that how can you approach towards the Newton's law of gravitation. And here sometimes they may give the force between the objects and you are maybe supposed to calculate distance or mass, whatever. Suppose if this is a formula that you need to use to calculate the given to calculate the required parameters in the numericals, you can find F value, anyhow G is constant, okay, and whatever the mass, if one mass is given and you may be asked to find the mass of the another object, and both masses and force will be given, and you might be asked to find the distance of separation. So whatever, 1, 2, 3, 4 unknowns are there. By knowing any three, the fourth unknown can be calculated. All right, and so this is the approach towards the force of attraction based one. Okay, all right. Yeah, Supriya, hi. Can you please explain it again? Yeah, see here. Yeah, sure, Ganesh, you can see here. There is a question here. The question is mass of the earth is given, mass of the moon is given, distance of separation is given. Okay, and you are supposed to calculate what is the force of attraction between those two objects. So according to the Newton's law of gravitation, it's very clear that there is a force of attraction between any two objects in the universe. So likewise, between these two objects, by you are given their masses, the distance of separation, and we have to calculate the force of attraction. So very simple, I just have recalled the force of attraction formula between those two objects. Mass of earth is given, mass of moon is given, distance of separation is given. I just substituted the values in the required form in this formula. After simplification, we'll get 2.0 into 10 power 20 Newton. Okay, hope I am clear to you, Ganesh. Do you have any doubts still? If you have, you can just let me know. I'll explain once again. Yeah, Supriya sir, can you say me what is mass? Yeah, next topic will be in the coming slides we'll be having difference between mass and weight. There I'll explain it. Okay, Just wait for a few more minutes. Just stay tuned. Okay, Ganesh, hope I am clear to you, and I'm moving to the next slide. Yes, free fall. So what is this free fall? You might have heard this word repeatedly. Okay, suppose if I drop any object, okay, then whether the object will stay here or it will move towards the earth surface. No doubt, undoubtedly the object will be moving towards the earth surface. Why? Here actually there is no force is being applied on the body. I did not throw or I did not push the body here. Just I dropped or else I released freely. What will happen? It's moving means definitely there is an influence on the body, but there is no any external influence applied on it. So the influence here is because of gravitational property of the planet. As we are on the surface of the earth, so the body which is released will be moving towards the earth because of the gravitational influence. So free fall is nothing but if the object moves under the influence of the gravity alone. If object moves under the influence of gravity, okay, then we can say it is under free fall. Freely falling body, just releasing an object, dropping an object, dropping a pen or dropping a book. Okay, so that will be considered as a free fall. One important point here, object moves under the influence of the gravity. Now as we are whatever the numericals or whatever the properties that we are going to learn, as we are on the surface of the earth, so we will relate to the earth's gravity and we will discuss. But these properties are even applicable to other planets also. What I mean to say is, as we are on surface of the earth, every time we used to talk about earth's gravity, its gravitational acceleration due to gravity, and then its mass, its radius, those parameters we are going to calculate, we are going to take into account. Suppose if you are talking about any other planet, we will talk about that planet's mass, that planet's radius, just like that. Okay, but the same thing will be applicable even there also. Okay, so if object moves under the influence of gravity, then we can say that object is under free fall. Then object is said to be under free fall. Okay, here if you take two objects which are having masses m1 and m2 and let they are released from the ground, okay, let from the same height, if the both objects have dropped, then which object will reach the ground, which object will reach the ground first? That's the question here. Here the answer is both m1 and m2 will reach the ground first, because when the bodies are executing free fall, they will be acting like weightlessness. Though they are having certain mass, but during free fall they will be executing massless property, weightlessness property. So due to that, both it's just independent on the mass what they are having, whether here m1 less than m2 or vice versa, reversal, or doesn't matter. Whatever the mass that the body is going to have doesn't matter. If they are released from the same height, both objects are going to reach the ground simultaneously. Just the fundamental property behind it is, when the bodies are executing free fall, they will be experiencing weightlessness property. All right. So here it's just due to weightlessness. Due to this weightlessness property, both objects will be having zero weight and they will be reaching the ground at the same time simultaneously. Zero weight in the sense it is completely independent on the mass of the body. Okay. Relation between small g and capital G. What is this small g? So just now I said here object moves under the influence of the gravity, right? Okay. So here When the object is free fall, under free fall, or if it is traveling under the influence of the gravity, it will acquire the acceleration of the planet. As we are on the surface of the earth, this earth will pull the object with certain amount of force. That's what we are calling it as gravitational force. That gravitational force is responsible for creating, accelerating, or for accelerating the body. What is that acceleration then? Acceleration of that body, only we are calling it as acceleration due to gravity. Suppose here if I say this is the surface of the earth, let mass of the earth is capital M, where its radius is capital R. Okay, now there is a small object whose mass is M, say small m, and now here the weight of this object, weight W is equals to mg, which is acting downward. Okay, so here weight of this object is acting downward, whereas there is a force of attraction between this object and this object, because these two objects are having certain mass, so there is a force of attraction between them. Then force F is equals to G m1 m2 by r square, say it is. Over here F is equals to G into m1 means mass of the earth, m2 means mass of the body, let r is the distance between them. So the gravitational force between these two objects will be equal to the weight of the object. Since the body is over here, the weight of the object here is equal to the force of gravity that is applied by the surface of the earth. So I can say here F is equals to weight, that means mg is equals to G mm by r square. Small m, mass of the body both get cancelled each other. Small g is equals to G m by r square. So this is the relation between small g and capital G. Small g is acceleration due to gravity. Okay, and capital G is universal gravitational constant. All right. Yeah, Aslam did not understood which one, this one or previous one, weightlessness, I mean free fall, or this one. Yeah, respond Aslam, I'll repeat it. Relation between small g and capital G or free fall case? Yeah, respond Aslam, waiting for your response, man. Okay, fine then. I am recalling free fall once again. It might be the last case. Free fall is nothing but is a motion of an object under the influence of the gravity. If I drop any object, then that will be moving towards the surface of the earth rather staying here or going up. So it's just because of the influence of the gravitational force. So if the body is moving under the influence of the gravity, then such gravity alone, again here I can say influence of gravity alone, strictly if I speak, then the object is said to be under free fall. Okay, so here in the free falling case, if I take any two objects which are having different masses, and if the both objects are released from the same height, then I said both objects will reach the ground simultaneously. There won't be any time lag. If you neglect certain air friction and all, then both the objects will reach the ground simultaneously. Okay, that the conditions will apply. Air friction you have to neglect. For this we are having Newton's feather and coin experiment. What he has done, he has taken a chamber, where is like a glass chamber. He has taken both coin which is having some weight and feather which is light weighted, very light weighted compared to the weight of the coin. In the beginning he released both the objects from the same height, and coin has reached first. There actually he considered that air friction and all. In the next one, the empty chamber he made, empty chamber, which means that there is no air friction at all, just like it's like vacuum. So then he released. What happened then? Both the objects reached the ground, reached the bottom of the chamber over there simultaneously. That shows what actually? Weightlessness property. When the objects are released, when they are moving under the influence of the gravity alone, under the influence of the gravity alone, then both objects will be having weightlessness property. That means they will be independent on their masses. Just they will depend on acceleration due to gravity as well as the height from which they have released. If they have released from different heights, then different times maybe. But if they are released from the same height, though they are having different masses, they will reach the ground simultaneously. That's what I said, Aslam, in this concept. And coming to this one here, here I just try to establish the relation between small g and capital G. If I take any object of mass m whose weight is mg, which is acting downward, and here this object is bound to the surface with the help of gravitational influence caused by the earth onto this object. Say the gravitational influence between those two bodies is F is equals to g m1 by m1 m2 by r square. It's from the Newton's law of gravitation concept. And then here m1 I have taken it as m, mass of the earth, and mass of the body, and r is the distance between these two bodies as it is lying on the surface of the earth. So from here to the center I have taken it as r, which is the radius of the earth, I can say. Suppose if this is earth, this is the one, and gmm by r square, mm cancels, small g is equals to gm by r square. And here you can notice one important and interesting point: acceleration due to gravity here it is independent on mass of the body. You may take the mass of the body as x kg or x plus kg or whatever the number. The acceleration due to gravity which that body is having is completely independent of mass of the body. It depends on what then? It depends on the mass of the planet. Suppose we are on the surface on the earth here, so it depends on mass of that earth only, and radius of the planet, that means radius of the earth. The same formula will be applicable. Suppose if you are on the moon surface, then you have to take moon's mass as well as moon radius. If you are on some other planet, that planet's mass and that planet's radius you have to take. So which means that acceleration due to gravity is independent on mass of the body. It depends on mass of the planet on which it is in, and it depends on the radius of that planet. Hope I am clear to you. So this is the relation between small g and capital G. Okay. To calculate the value of g, suppose here as we are on the surface of the earth, I am talking about the value of g on the surface of the earth here. So we know that small g is equals to, we can write it as gm by r square. That means this is 6.67 into 10 power minus 11 multiplied by mass of the earth. What is this mass of the earth? As I am talking about mass of the earth, so it is 6 into 10 power 24 kg divided by radius of the planet. So planet earth, right? For planet earth, mass is what? 6 into 10 power 24 kg, and radius is it's 6 into 10 power 6 meter. Okay, so then here 6 multiplied by 10 power 6 whole square. If you simplify this, approximately will get 9.8 meter per second square. This is the value of g on the surface of the earth. Okay, why I am specifying here on the surface of the earth? Even this g value is not constant. Suppose if I take earth only, earth's g value we have obtained it as 9.8 meter per second square. Okay, just a minute. Ganesh is asking how f is equals to mg. Okay, fine. In the previous thing I think so. Just a minute. See here, the weight of this object is acting downward, right? And there is a force of attraction between these two objects, which is gm1 m2 by r square. Here this object is staying there only, which means the weight of the object is just balanced by some other force. What is that some other force? Force of attraction between these two only, right? So weight of this object is balanced by the gravitational force between these two objects. That's why I replaced force with weight. Ganesh, am I clear? That body is having some x Newton amount of weight, which that gravitational weight, I can say it's acting downward, but the body is not going right, that weight is balanced. It's balanced by the gravitational force over here. That's why I replaced here that gravitational force with weight. Yeah, okay, right. Fine then. Yeah, coming to this one. So G value we calculated. I am talking about G on the surface of the earth. So we got it as 9.8 meter per second square. This G is not same everywhere, even on the surface of the earth. Near poles, it's different. At equator, it is different. At equator, the value will be less than 9.8 meter per second square. And near poles, the poles of the earth, north pole and south pole, extremes if you are talking about, the value of G is more than 9.8 meter per second square. So it's not same even everywhere. How? I mean, why it's happening? It depends on the many factors. As I said, mass and radius only here I mentioned in this formula. But apart from this, the G value depends on latitude. That G value, acceleration due to gravity, will depend on shape of the planet. So the planet shape, we are taking them as in spherical, but exactly they are not spherical. All shape will be there, elliptical will be there. Even the paths along which they are traveling, that is also not circular exactly, elliptical orbits. So the G value will depends on many parameters. That's why the value of G here, 9.8 meter per second square, which we have obtained, is not same everywhere, even on the surface of the earth. That's what the point I am stressing here. Value of G varies from, suppose if you take this location from here to some other location, it's not even major but minor, but definitely change will be there. Especially we are talking about equator and poles. At equator, the value will be lesser than the 9.8 meter per second square. Near poles, the value of G will be more than that 9.8 meter per second square. Okay, so hope you have understood how G value will be affected, and more about this in class. Now in class 9 you are having gravitation. In class 11 you will be having gravitation again, just like fundamentals of this chapter, and many more content, interesting topics will be you are going to learn in class 11 gravitation chapter. Okay, fine. Yeah, NS Lucky, hi, how are you? Okay, fine then. So the value of G on the surface of earth is 9.8 meter per second square. Near equator, the value is less than G, 9.8 meter per second square. Near pole, it will be more than 9.8 meter per second square. The change in the value of G is because of the shape of the earth. That point you can stress over there. All right. So as we are on the surface of the earth, I have substituted the values related to mass of the earth as well as radius of the earth. That's related to earth. If you are talking about moon, you can take mass of the moon here. You can take radius of the moon. Then you can substitute. You will get some other G value. Say that is 1.63 meter per second square approximately. So value of G here depends on mass of the planet on which we are talking about, the object. It may not be planet, that object which we are going to talking about. If you take earth or moon or sun or Jupiter or Mars, any other planet, those values. Similarly, their size, that means that radius. Okay. Yeah, next one, motion of objects under the influence of gravitational force of the earth. All right, very important one. So here, free fall case we have seen, when object is released freely or dropped freely, it will be traveling under the influence of the gravitational force of the planet. Sorry. If you are talking about the earth, the influence over here is earth's gravitational force. Okay, it's not only related to the freely falling, even if you will project the object now in upward direction, so there on the bodies whichever are moving in upward direction, on those bodies also gravitational influence is there. So whether they are moving downward or upward or at certain height from the surface of the planet, you may take earth or you may take some other planet, so there also gravitational influence will be there. So now we are going to talk about that gravitational influence on the objects which are moving either upward direction or downward direction. Okay, Ganesh sir, this is 10th class. No, this is class 9 NCERT I am talking about. It's a class 9. In class 10 you are not having gravitation, right? I mean, if you are under NCERT curriculum, and almost the Class 9, grade 9 only we are having this gravitation. Okay, fine. So, okay. Here I will connect these the equations of motion which you have learnt in chapter 8 motion. Okay, in motion we are having, you have learned these equations if I am not wrong. V is equals to u plus at, s is equals to ut plus half at square, v square minus u square is equals to 2as. So these three equations we are calling them as equations of uniformly accelerated body. Equations which are applicable to uniformly accelerated body. If an object is accelerated uniformly, then you can apply these three equations. This we'll call it as velocity and time relation. This we'll call it as position and time relation. This we'll call it as velocity and position relation. Okay, so these equations can be applicable to an object whichever will be moving uniformly accelerated. Whichever will be uniformly accelerated. So then why should we recall these equations here? Say suppose with respect to the ground, either I have dropped an object freely, or else if I project the object in upward direction, these both objects will be moving under the influence of gravitational force of any planet. As we are on the surface of the earth, we will talk about earth. So these two bodies will travel, these two bodies will be under motion under the influence of the gravitational force of the earth. That's why they will acquire the acceleration due to gravity of that planet. So whether the object is moving downward or whether the object is moving upward, they will move under the influence of the gravitational force. So they will acquire the gravitational acceleration due to gravity. The acceleration as acceleration due to gravity, which I can say the A is equals to G. So the acceleration of the body there, it is because of the acceleration due to gravity, which is provided by the gravitational force of the planet. That means gravitational force between those two objects. So you can replace that A with G. Here A means uniform acceleration, and whereas G is also uniform acceleration due to gravity. So every time we won't pronounce it as, we won't call it as uniform. Of course that will be uniform only. So these equations, three equations which we have obtained in motion chapter, will be applicable even in these cases also. Since if you take these two bodies, they are moving here. One thing is they are moving in straight line, either moving downward or moving upward, and they are moving under the influence of acceleration, under the influence of gravitational force that provides uniform acceleration, whose value is equal to acceleration due to gravity of the planet. That means these bodies will be traveling with uniform acceleration only. So you can apply those equations of motion here. Okay, then see how I am going to apply those equations here. First I will take free fall case. Very important this is. So under free fall case, the initial velocity of the object is 0 meter per second. Why? Since it is dropped freely, it's released freely. There is no initial velocity that is provided or given to the body. It just dropped. So it will move under the influence of gravitational force alone. That is what free fall I said. Then initial velocity is 0. Acceleration due to gravity is g meter per second square. A is g, you can say it as 9.8 meter per second square. Okay, you can apply based on the value, doesn't matter. One more thing here, when object is coming downwards direction here, you can apply the sign convention. Sign convention here I am giving children. So this sign convention, conventionally it's based on choice. They may consider, like few people may take positive upward going for upward motion physical quantities, they may assign positive sign. Downward one they may assign negative sign. So it depends on their conventional choice. So I feel convenient in one certain type, and I may consider this, like what, if an object is traveling downward direction, it's a downward direction, I will take acceleration due to gravity as plus g meter per second square. Okay, since I am taking this in my conventional point of view, like it's moving towards the surface of the center of the earth. So it's directed towards the center of the earth. It's directed along the direction of influence of the gravitational force. So I am taking A value as positive. Suppose here in this case, if you see, body is projected upward direction, which means it's traveling in upward direction. That direction is opposite to the influence of the gravitational force. So for upward direction, I will take A as minus G. This is for downward motion and this is for upward motion. Even while solving numericals also, if I am talking about the object which is traveling in upward direction, I will take the acceleration due to gravity with a negative sign. If the object is traveling downward direction, if traveling in downward direction, then the acceleration due to gravity I will take it as positive sign. Okay, somewhere else you may see it is in reverse direction. That conventional thing is different. So how I am feeling, it's just a convenience point of how I am thinking. Okay, and that should be acceptable. Convenience means however you want, you should not take. I have taken here G as positive since when it is traveling downward, it will be traveling under the influence of gravity, and the direction of the motion is along the direction of influence of the gravitational force. I have taken it as positive. And the same object is projected in upward direction, it's moving against the gravitational force. It's moving upward direction. So then its G value, the velocity of the body is going to be decreasing gradually. Just because of what? The motion over here, it is opposite to the direction of influence of the gravitational force. That's why the value I have taken it as minus G when for upward case, and it's plus G for downward case. Just as I said, it's someone said, yeah, Ganesh, it's minus G. So it's just conventional. Fine then. So here when I take the free fall case, when object is traveling downward direction, that to free fall case, that's very important one. Initial velocity you have to take it as 0 meter per second, and acceleration due to gravity 9.8 meter per second square. And here if the body is projected in upward direction, then definitely by itself it can't go. Here it is already from certain height it is dropped, okay, and then if it is released it will come down. But to throw the object to reach this position, you have to give some initial velocity to the body, say it as u meter per second, when the body is going upward direction, and the influence of gravity there over here I'll take it as minus G A value. So now for this downfall body, downward moving body, and this upward moving body, how can you apply those equations? Let's see once. Okay, what signs are used, Ganesh? Sir, it travels in left and right. See, even if it is left and right direction also, gravitational influence there. Suppose from here if the body is traveling in this direction, okay, so there that velocity will be there, then the body may acquire some other acceleration, the resultant acceleration also we may take. That case is different, but there also these equations will be applicable, same sign conventions will be applicable. You don't worry about then. Just in this upward and downward case you can remember here. Yeah, A value will be there only. See, it just depends on, here you can apply here this plus G or minus G when the body is moving upward or downward. Here suppose from here if it is going in this direction, okay, acceleration due to gravity will be there, that is fine, but that sign convention doesn't matter since here it is at constant height, it is traveling like this or like this. Then the body may acquire its own acceleration since its velocity may change gradually. Then horizontal, that will apply equations of motion, then what acceleration will be there for the body, that we will take. Okay, so then yeah, so equations of motion here, how we can apply for free fall. For freely falling, V is equals to U plus AT. So then how can you write then? Initial velocity is 0, acceleration due to gravity G, so it is T, so V is equals to GT. Alright, then S is equals to UT plus half AT square. As it is at certain height H, I will take S as H. H is equals to half GT square since U 0 here again. Similarly, V square minus U square is equals to 2AS. We can write this as V square is equals to 2GH then v is equals to root over 2gh. So from this one you can find the time taken by the body to reach the ground. So t square is equals to 2h by g we will get, then t is equals to root over 2h by g, where this t is called as time of descent. Time taken by the body to reach the ground is root over 2h by g. Okay. So then upward moving body, if you say, for upward moving object, how can we apply the equations of motion? V is equals to u plus at, right? So V is equals to u, say a as minus g here. For this case I said a is equals to minus g. So under free fall u is equals to 0 meter per second you should take, a is equals to plus g. Then here v is equals to u minus gt. This is one case. And then this equation will become, second equation will become h is equals to ut minus half gt square. It's ut minus half gt square, and similarly v square minus u square is equals to minus 2gh. Like this the equations will become. So for this upward projected body at maximum height, very important case this is. That means if I project an object with certain velocity, that object won't go continuously, right? There is a point at which its velocity will become 0. So the point at where its velocity is becoming 0, that's what we are calling as maximum height reaching point. So in such case, at maximum height, final velocity will become 0 there, point, right? So this expression if you check, h is equals to u, sorry, yeah, this one, yeah, this one if you see here, v value 0, right? 0 square minus u square is equals to minus 2gh, then minus u square is equals to minus 2gh, then h is equals to u square by 2g, this h only, h max means maximum height of the body. If I project this object with certain velocity u here, if this is the height, that greatest height it can cover, that will become h max, where at h max final velocity will become 0. H max is the greatest height covered by the body at where its final velocity will become 0 when object is projected in upward direction with certain velocity. Okay, so very important one. And even here you may take this equation here, u is equals, v is equals to u minus gt. From this you can say here 0 is equals to u minus gt, then gt is equals to u, then t is equals to u by g. This is called time of ascent. Time of ascent is nothing but time taken by the body to reach the greatest height. So if I project this object from here with certain velocity in upward direction, whatever the time that is taken by the body to reach the greatest height, that time we are calling it as time of ascent. And after reaching this point, again the body will be traveling in a downward direction just because of the influence of gravity. Then it will become free fall. Then time taken by the body to reach the ground is called time of descent. Time of ascent plus time of descent together we will call it as time of flight. Time taken by the body to reach the ground when it is projected upward. I mean, if I project the body in upward direction, going up and coming down, the total time taken by the body to do this one, we are calling it as time of flight. Time of flight is equals to time of ascent plus time of descent. Right here there is a question based on this equations of motion. An object is thrown vertically upwards and rises to a height of 10 meter. Okay, calculate the velocity with which the object was thrown upwards and time taken by the object to reach the highest position. So first one, from here object is projected. Okay, say the initial velocity u, which we have to find out, and this is the position at where it has reached, and this is h max, let it is. Okay, so then height is what? Height is given 10 meter. We know that, just now we know that's what, h max is equals to u square by 2g, right? H max value 10 meter is given, and u value we have to find. Take g value 9.8. So 10 multiplied by 2 into 9.8 will become 19.6. That's equals to u square. U square is equals to 19.6. Then u is equals to, sorry, this 196. U is equals to root 196. 14 squares are 186. Then 14 meter per second is the initial velocity. So you can apply directly here by using this Hmax formula. You can calculate the given initial velocity. When 11th gravitation chapter will start? Now in which standard you are in, Ganesh? Are you in class 9 or class 10? Okay, fine. So we have calculated velocity with which the object was thrown upwards. Then time taken by the object to reach the highest position. That's what we call it as time of ascent, right? Okay, dropper, no problem. Which is standard? 9th or 10th or 11th, that's what. That's okay, Ganesh, no problem. I am just asking you dropper from which class, 9 or 10 or 11. Okay, all right. So initial velocity we have found, that's 14 meter per second. What's the time taken by the object to reach highest position? To reach highest position, that's what we said, we discussed it as time of ascent, which is u by g. So u value 19.6, sorry 14, right? Just a minute. U value it is 14 meter per second and it's 9.8. Approximately you will get some 1.43 seconds. Okay, suppose if it is 10, it is 1.4, then 9.8 is, it will be more than 1.4, so nearly 1.43 seconds. Okay, 12th class. All right. Okay, fine. So next coming summer, we are having summer crash, summer course. In that you can join. So there class 11, for class 10 people, class 11 will be started. And there in class 11, you will be having gravitation. Okay, if I am not wrong, that is the end of the first part. Most probably it is 8th chapter. Okay, fine. So this is how you can calculate. You can apply the equations of motion when the object is moving under the influence of the gravity. Yeah, this is class 9, of course, Aslam. So this is the method of approach to calculate height, maximum height as well as time of ascent. Right. Next one, mass and weight. Yeah, someone asked what is mass and weight? What is the difference between mass and weight exact? In the beginning of the session I can say. Yeah, so see, here is the topic. So basically, physical, when we are discussing general discussion, we may treat both mass and weight almost, not almost, the same only. Like what is the weight of the object? Suppose if I ask you what is your weight, then you may say, then some say 50 kg, 40 kg, 30 kg, 55 kg. So actually there, what you are representing is not weight exactly, it's mass. Say one more thing, when you are expressing it, you are saying write it as what? Some 50 kg. Kg is what here? Kg is unit of mass. Mass unit is kilogram, SI unit. Then weight is what then? Weight is different. Weight and mass both are not same. Weight and mass, they are not same, they are different. But physically, generally if you are communicating what's your weight, we may say that some 50 kg, 30 kg, actually it is mass. But when it comes to physics, both are not same. That's different. Mass is different, weight is different. Then what are they exactly? Mass is its amount of matter. That's what we are measuring it in terms of kilogram. But then weight is what? Weight is a kind of force. It's a kind of force which depends on mass of the body as well as acceleration due to gravity of the planet or surface on which we are in, or which we are relating it. That means weight we use it to express it. W is equals to mg, whereas m represents mass here. So weight depends not only on the mass of the body as well as the gravitational influence that is having due to any other object. So that is equals to mg, we can write here, W is equals to. So as it is a kind of force, I said, then SI unit of weight is Newton. So weight is expressed in terms of Newton. Mass is expressed in terms of kg. Weight is a kind of force. It's a gravitational pull. All right. Okay, so see here. Then this, if I say this weight W is equals to mg here, okay. There is another important point and interesting point here. If I am talking mass of an object, if I take any object whose mass here is some 10 kg, okay, and I am talking about the weight of this object on the surface of the earth. So on the surface of the earth, the weight of this object is the mass multiplied by the gravitational due to acceleration due to gravity on the surface of the earth. So m value 10 multiplied by acceleration due to gravity of surface of the earth is what? So say it is 9.8 approximately, then you will be having some 98 Newton. Okay, now if I'll take the same object, onto moon or onto any other planet, then weight won't be same. It won't be 98 Newton. It never ever be 98 Newton. But its mass will be definitely 10 kg only. That means mass remains same. It's constant everywhere. Mass is constant here. It's constant everywhere. Whether you are on the surface of the earth, or you are on the surface of the moon, or you are on the surface of any other planet, the mass of the object remains same, but not weight. Weight is equals to what I said here. It depends on both mass of the body as well as acceleration due to gravity. Mass remains constant, fine. Then what about acceleration due to gravity? That will be changing, keep on. Keep on in the sense it depends on the planet on which it is in, on which it is. So if I am, as I am on the surface of the earth, so I will talk about the acceleration due to gravity of the earth. Now I will take the same object onto the moon. So then in such case, the weight is not that 98 Newton. Then weight of that object is equals to mass multiplied by acceleration due to gravity on that planet. Suppose if I am talking about moon, then weight of the object on moon is equals to mass of the body, multiplied by acceleration due to gravity of the moon. So that value will be some approximately 1.64 meter per second square. Again, how to calculate this g value? I said already, by using this relation. So we will calculate the g value belongs to that planet, and we will take and we will substitute here. So you will get weight of the object on that planet. Hope I am clear how to calculate the way, how to differentiate between weight and mass. So simple one crystal clear statement, that is mass of the object remains the same. It's constant everywhere. You can't change it. But whereas weight of the object will depend on mass of the body as well as acceleration due to gravity. Okay. So here, next one then, weight of an object on the moon. So if I want to calculate weight of the object on the moon, then you should know, Athar. Hi. Worried about exams. Don't worry, Athar. Okay. You just we have completed all these one shots, and most of the chapters are completed, and few more topics are we are going to finish it. Timetable schedule is given. Just follow the schedule. For reference, you just watch the previous videos. Still, if you are unable to clear up your doubts and all, just approach us, download the practical app and approach through the Seek Help team that is existed, so that we can reach out. Okay, we can clear whatever the doubts that you'll be having. So weight of the moon, what I said, it depends on mass of the body as well as acceleration due to gravity. Whose acceleration due to gravity? Acceleration due to gravity of the moon. Then how can you relate it? Generally, acceleration due to gravity on the moon is 1/6 times of acceleration due to gravity on the earth. Okay, so weight of the object on the moon can be written here as m into acceleration due to gravity of the earth by 6. That means 1/6 times of weight of the object on the earth. This is the relation here. Suppose if weight of the object on the moon, on the earth suppose if I say on the earth it is 60 Newton, then weight of the object on the moon is 60 by 6 times, that means 10 Newton. Okay, so this is how you can calculate. Chandana, yeah, hi, good evening Chandana. So the relation between weight of the object on the moon and weight of the object on earth is like this. Weight of the object on the moon is 1 by 6 times of weight of the object on the earth. If an object weighs 60 Newton on earth, the same object weighs 10 Newton on the moon. But so suppose here if I say g value some 10 meter per second square approximately, then what might be its object's mass here? Suppose if I take this weight of the object on earth is what? 60, right? So then this you can write it as m into g is equals to 60 here. That means m value I want to find, m is equals to 60 by ge. Say then acceleration due to gravity is some 10 meter per second square approximately. Then 60 by 10, how much you'll get? Some what? 6 kg. So see here, mass of the object is 6 kg. This 6 kg is same everywhere, even on the planet of Earth or even on the moon. But acceleration due to gravity is not like that. Acceleration due to gravity on moon is different, Mars is different, Jupiter is different, Earth is different. Just like that. Afsana, good evening. Yeah, there is a question here. An object weighs 10 Newton when it is measured on the surface of the earth. What would be its weight when measured on the surface of the moon? 10 Newton. So same example. Okay, fine. Just now we discussed here. Weight of the object on the earth is 10 Newton. Weight of the object on moon is 1 by 6 times the weight of the object on earth. Okay. What would be its weight when measured on the surface of the moon? So it will be 10 by 6. That means 6 ones are 1.67 Newton. Okay, 1.67 Newton. So you can calculate like this. And apart from this, okay, about this gravitational force generally. So see here, suppose if I take a thread, to the thread or any rope kind of thing, just to tie a stone, and if you hold this edge and if you will wheel it, it will be traveling along the horizontal circular motion, or you can take vertical circular, so it doesn't matter, no problem. And suppose if I am wheeling it, if I release the body while wheeling, then if I say here, this is the tension force which is acting along the string, right? So if I release the body, this body will be traveling along the tangential direction. So this tension force which is acting towards the center, we are calling it as centripetal force. Okay, and here the object, when it is released, it will travel along the tangential direction. Similarly, if you take the motion of these planets, one object will be traveling around the another object. Motion of the satellite you can take. Okay, best example, motion of the satellite around the earth you can take. How those satellites are bounded to the surface, along those particular orbits? Just because of gravitational force. So there the gravitational force of attraction will be acting. It will be acting towards the center of the earth. That force there we are calling the centripetal force. So here gravitational force is an example for centripetal force. All the gravitational force, all the centripetal forces won't be gravitational force here. Gravitational force is centripetal force in this example. Like tension is centripetal force in this example. So centripetal force is nothing but the force which is acting towards the center here. And it's a real force. Opposite to the centripetal force, we are having a pseudo force which we are considering it, we are talking about centrifugal force, which is an imaginary force. Okay, so gravitational force is a centripetal force. Planets revolving the planets around the sun, or else motion of the satellite around the earth, these are all what? They are bounded with the help of gravitational force, which we are calling it as centripetal force. Alright. Yeah, then think, yeah, fine. That's all about the gravitation, and that's all about today's session. As I said, actually in class 9 NCERT, continuation to this topic, in this chapter itself we are having fluid statics, fluids part also, but for this term 2 examination in NCERT we are not having that fluid, so it's removed from the syllabus, and I don't know whether next year it may be added based on the time, that and all. Sir, explain it again, Ganesh. Which one? That centripetal force, right? See, the planet, motion of the planet around the solar system, or you can take motion of the satellite around the earth. Satellites will revolve around the earth, right? Yeah, centripetal and centrifugal. Okay, fine. So then those objects are revolving around the earth. That means there is a force of attraction between those two objects, which we are calling it as gravitational force. That force will be directed along that radius, that radially inward direction. The force which is acting along the radially inward direction, we are calling it as centripetal force. Centripetal force always will act along the radial inward direction. Then radially outward direction will be there. So that again you have to consider while applying that. You have to consider that inertial and non-inertial frames, that and all. Okay, I am not going to into that much depth. Just you can remember those centripetal and centrifugal force. Here in this motion of the satellite around the earth, the force which is acting radially inward, that means towards the center, that we are calling it as centripetal force. In this example, centripetal force is a gravitational force. So gravitational force is an example for centripetal force, I am saying. And in the same example, motion of the satellite around the earth, an imaginary force that will act radially outward direction, that we are calling it as centrifugal force. There in both the cases, centripetal force and centrifugal force experiencing is F is equals to mv square by r. Both can be represented. So I am saying that all the centripetal forces are not gravitational forces. Gravitational force is an example for centripetal force. If you take the string, if you tie the bob to the edge of the string, and if you are start wheeling it, their tension will be acting along the circle, along the radius. So their tension is also kind of force. Tension is an example for centripetal force. So centripetal force here, basically in these examples, it will be acting towards the center of the circular path along which they are traveling. And there an imaginary force which is acting radially outward, we are calling it as centrifugal force. There its value is mv square by r. If I say m is mass of the body, v is with what velocity it is traveling, r is the radius or distance between those two objects, then it will be mv square by r. Okay. And some other centrifugal force are there, that's different. So centrifugal means it's an imaginary force. Okay. Hope I am clear to each and everyone about the topic that which we are having. Still, if you are having any doubts, just download the Practically app, and we are having Seek Help team, and you can ask any doubt anytime at any time. I mean, in the available hours, we'll just respond to your doubt. We'll give a clarity on that. Fine then. Subscribe to the channel for the existed videos, and for the upcoming sessions, just stay tuned to the Practically YouTube channel. And for today, I am signing off. Thank you.